Hello everyone, welcome back to our channel. So today we are going to try to prove that the sum of opposite angles of a cyclic quadrilateral is 180 degrees, or we could say they are supplementary. So what this means is, first let's draw a circle. So we have our circle. Now let's say the center of the circle is over here. Our center is O. Now, what we mean by a cyclic quadrilateral is a quadrilateral whose four corners or vertices are at the circumference of the circle, okay? So, for example, let's say one of the point of our quadrilateral is over here, another point is over here, let's say our third point is over here, our last point is over here, okay? So, we have our four vertices of the quadrilateral touching the circumference. So, let's connect these points and we get our quadrilateral, okay? So a tip for you is try to make these 3 points close to each other, okay? Because if you try to make them like a square shape, then sometimes the central angle, which we'll make later in this video, becomes a straight line and it'll be a little bit difficult to make the correct figure, okay? So here we have our now cyclic quadrilateral. Let's name this quadrilateral A, B, C, and D. Now, what our theorem tells us is that the sum of the opposite angles of this cyclic quadrilateral is 180 degrees. So, if we add this angle D and angle B, we would get 180 degrees. And if we add this angle A with angle C, right, the opposite angles, again, you'll get 180 degrees. Now, how do we prove this theorem? So, to prove this theorem, we need to know two basic things. And sometimes students just don't understand these two basic things, which makes it difficult to understand this entire theorem, okay? So one of those basic things is, let's say we have A, B, C like this, okay? So usually when we look at these two lines, we only see one angle, which is this angle, right? Angle ABC is this angle. But we also have another angle over here, okay? This angle is also angle ABC. This angle down here is the obtuse angle ABC, right? Obtuse angle ABC. And this angle right here is also angle ABC, but it's the reflex angle, okay? So reflex angle ABC. These both angles are angle ABC. This is the first thing that you need to know. The second basic thing is when you add these two angles, right? The obtuse and the reflex angle, you get a complete circle, okay? And when you add these two angles, you'll get the total sum as 360 degrees. Why? Because it just forms a complete circle, and a complete circle is 360 degrees. So that's our second thing that you need to know. So if you understand these two things, it's a little bit easy to prove this theorem. Now, we need to make a construction to prove this theorem, okay? So we are going to join this A with our O, and then join this O with our C. Now, the way we are going to prove this theorem is that let's say this angle D is our X, and let's say this angle B is our Y. Then, from our first theorem on circle, we know that this central angle is double of inscribed angle made on same arc, okay? So, this angle X is made on this AC arc, okay? This arc. And then this central angle AOC is also made on this same arc, AC. So this angle should be double of this inscribed angle made on same arc. So it's going to be 2x. Similarly, when we look at this reflex angle AOC, okay, this is also a central angle because it is also formed on the center, right? But this angle is made on this arc, okay, AC arc, but the bigger AC arc or the major AC arc, okay? And we have our angle Y, right, circumference angle, also made on this bigger AC arc. So if this angle, our inscribed angle is Y, then this central angle made on same arc should be double, right? So it should be 2Y. Now, we just discussed before that the sum of these two angles, right? The reflex and obtuse angle is 360 degrees, right? So similarly, this 2x and 2y when added together should give us 360 degrees. So if we add 2x plus 2y, this should give us 360 degrees because it forms a complete circle. Now, when we take 2 common, we get 2 bracket x plus y is equal to 360 degrees. And when you move that 2 to the other side, we get x plus y is equal to 360 degrees divided by 2. And therefore, we get x plus y is equal to 180 degrees. And we have just proved that the sum of this x and this y is equal to 180 degrees, right? So the sum of the opposite angles of a cyclic quadrilateral is 180 degrees. And similarly, if we had made the construction like this, right, joining D and O and then D and B, again, we could do the same thing with this angle A and angle C, assuming they are like Z and let's say M. And again, we would get like this angle is 2M and that angle is 2Z, right? And we would again get M plus Z is 180 degrees. So in this way, we just proved our theorem, right? The sum of opposite angles of a cyclic quadrilateral is 180 degrees. Now, let's write this formally, okay? So I'll just erase all the rough things that we did over here, right? Now, let's prove this theorem formally. So first, we have our solution, and then we have our given. In our given, what we are going to write is O is the center of the circle, and ABCD is a cyclic quadrilateral. That's given in our question, right? So O is the center of the circle, and ABCD is a cyclic quadrilateral. Now our second part is to prove. We need to prove that angle D plus angle B is 180 degrees and angle A plus angle C is 180 degrees, okay? So angle B plus angle D is equal to 180 degrees and angle A plus angle C is also equal to 180 degrees. Now we also made a construction, right? So construction, we connected our A with our O and O with our C. So join A and O and O and C. Now our final part is our actual proof. So in our proof, we are again going to have statements and reasons. So I've just copied the mini version of our figure over here. So in our number 1, what we are going to write is this angle AOC, right? The obtuse angle AOC is 2 times this angle D, okay? Because it's a central angle and this is inscribed angle made on same arc AC. So obtuse angle AOC is equal to 2 times angle D. Okay, so this is from our previous theorem, that is central angle is double of inscribed angle made on same arc. So our reason is going to be relation between central angle and inscribed angle made on same arc. Similarly, in our number 2, what we can do is this reflex angle AOC is twice this angle B, okay, because they are made on the same purple arc, okay, AC arc. So reflex angle AOC is equal to 2 times angle B. Again, the reason is same as 1. Now in our number 3, what we are going to do is we are going to add this obtuse angle AOC and the reflex angle AOC. This will give us 360 degrees, okay, because it forms a complete circle. So complete angle. Now we are going to write a new statement by combining all these 3 statements, okay? So instead of this obtuse angle AOC, we are going to write 2 angle D, and instead of this angle reflex angle AOC, we are going to write 2 angle B, because AOC is equal to 2B and obtuse is equal to 2D. So we have obtuse AOC is 2 angle D plus reflex AOC is 2 angle B is equal to 360 degrees. So this is from all those 3 statements. So from statement 1, 2, and 3. Now, in our number 5, if we solve this, right, we can take 2 as our common, which will give us angle D plus angle B is equal to 360 degrees. When this 2 goes to that side, it's going to be divided by 2, right? And we get angle D plus angle B is equal to 180 degrees. And we can write that as angle B plus angle D is 180 degrees, right? So angle B plus angle D is equal to 180 degrees. We got this by solving statement 4. And hence, we have got that this angle D plus this angle B is equal to 180 degrees. Similarly, we can also prove that angle A plus angle C is 180 degrees by joining this D with O and O with B. But we are not going to do all those stuff, okay? We're going to write directly in our number 6, angle A plus angle C is also equal to 180 degrees. And our reason is going to be same as above. You could write here by joining DO and OB as well, right? By joining this D with O and O with B, but it's not compulsory, okay? And proved. We have proved our theorem. So the sum of opposite angles of a cyclic quadrilateral is 180 degrees, or you could say it's supplementary. And that's it. So if you enjoyed our video, please give us a thumbs up and subscribe to our channel for future maths videos. Thank you.